Hi friends, our next chapter is atoms. In this chapter, we'll know about the structure of basic unit of matter, that is atom. Now, you know that atom has some subatomic particles. They are electrons, protons, and neutrons, right? They were first discovered by J.J. Thomson. One subatomic particle, that is electron, was discovered by J.J. Thomson by his experiments on electric discharge through gases. Now, that revealed that there were negative charged particles, that is electrons. But on the whole, atom was neutral. So obvious argument will be that atom should also have positive charge. So basing on this, J.J. Thomson itself tried to give a model. He called it as plum pudding model. It is that he said that the atom resembled a watermelon. He said that the positive charge was uniformly spread all over the atom and negative charges were placed inside the atom as if seeds are placed inside a watermelon. But this model was not satisfactory because it couldn't explain many effects. So we had to move for something else. Later, a scientist named Rutherford did his experiment, which is famously called as alpha particle scattering experiment. And through the observations he got, he tried to give the structure of atom, and that was a major step in deciding the structure of atom. You see this? It is called Rutherford's nuclear model of atom because he is the one who discovered the nucleus. Once I'll explain the experiment, you'll understand what he did. First of all, he focused a beam of alpha particles. You know what are alpha particles? Alpha particle is nothing but helium nucleus. That is, those are the particles which have 2e charge, positive charge, and they are having a mass of 4 atomic mass units. So they are very powerful, and the experimental results were something unexpected. He focused a alpha particle beam onto a thin gold foil. This is very thin, almost 10 power minus 7 meters, so thin. And after that, there was a mechanism to detect the rays. And so, what he observed was that many of the rays passed through the foil in a straight manner, but there were some rays which were deflected by some angle. You observe this? These rays. And there were some rays which were deflected by large angles. Of course, they were less. Many of the rays were passed easily, that is, in a straight way. Now, Rutherford argued that to deflect an alpha particle, that is, consider these rays, to deflect an alpha particle, you need a very, very strong force. That is what he argued. And alpha particles had a positive charge, right? So there should be some positive charge which is deflecting the alpha rays back. And to deflect the alpha rays, that needs to be very strong because if the positive charge was uniformly distributed, that force wouldn't have been enough to deflect alpha particle. So he said that there should be positive charge concentrated at a very small area so that it was strong enough to deflect the alpha particles. That was his first argument. And later he also said that since many of the rays traveled without any deflection, that is undeflected, they were not deflected, right? Since many of the rays traveled undeflected, he said that much of the atom was empty space and there was positive charge concentrated at in a very small volume. That is his second argument. So basing on that, he tried to give the structure of atom in this way. This is what he said: in a very large volume of what atom, a small fraction was occupied by the nucleus. And don't misunderstand, I don't mean atom has very large volume. I mean to say that when compared to the volume of atom, nucleus occupied a very, very small fraction. That is, actually, by kinetic gas theory, we know that the size of atom was in this order, 10 power minus 10 meters. This was the size. And according to his experiments, he this was the what graph that gave the number of particles deflected in certain angles. So if you observe, there were very few particles that were deflected by an angle which is more than 90 degrees, and there are many particles which are not much deflected. So through these observations, he said that much of the nucleus was empty and only a Small volume of it was occupied by the nucleus, that is the positive charge concentrated. And using these numbers, the number of atoms deflected in certain angles, using these numbers he made calculations and calculated that the atom should be at least 10,000 times or 1 lakh times greater than the nucleus. That is, he said that the nucleus should be of the order 10 power minus 14 or 10 power minus 15 meters, of this order, very small, right? So, as most of the atom is empty space, alpha particles go through the foil or the metal foil undeflected. Well, that's fine. What about the electrons? Because electrons are so light, right? So they don't appreciably affect the alpha particles. And this is a gold foil, right? And atomic number of gold is 79. So here the at the nucleus the positive charge should be 79e, and the coming positive charge of alpha particle is 2e, right? So this should be able to deflect the alpha particle, because anyway, even in terms of mass, the gold nucleus is something 50 times heavier at least than the alpha particle. As you observe, the trajectory of alpha particle mainly depends on the impact parameter. What is impact parameter? It is the perpendicular distance of the initial velocity of any alpha particle, say. This is the perpendicular distance of initial velocity of the alpha particle from the center of nucleus. So this will be the impact parameter of this alpha particle, and for this alpha particle this will be the impact parameter, just the perpendicular distance of the velocity with the nucleus. This is the atomic model that finally Rutherford gave it. So he said that the mass, entire mass of atom was mainly concentrated at the center, that is nucleus, and also the positive charge was concentrated at the nucleus only, and electrons revolve around the nucleus in orbits, and these are the orbits which you are seeing. He said that electrons revolve around their respective dynamically stable orbits. See, the nucleus is positively charged and the electron is negatively charged, so there will be electrostatic attraction between that, right? And the electron is revolving around the nucleus. So Rutherford said that the electrostatic force that is acting between the electron and the nucleus provides the centripetal force to keep them in that circular orbit. So for that, what is the condition? You know that when a body is of mass m is revolving in a circular orbit of radius r with a velocity v, then the centripetal force will be mv square by r, right? And this should be equal to the electrostatic force between nucleus and electron. So in a case of hydrogen atom, the positive charge at the center will be E also, and the electronic charge will be also E. So it should be E square by R. This R square, sorry. So from this equation, you can say that the radius of each orbit is given by E square by 4 pi epsilon naught mv square. So here it depends on the velocity of electron. This is the relation between radius of orbit and velocity of that electron. So you can say that velocity of electron is different in each of the orbits. Now, if the electron has a velocity v, then the kinetic energy of it will be half mv square, right? So from this equation, you can get what is v square, right? So if you put that value here, you are going to get e square by 8 pi epsilon naught r. This will be the kinetic energy in terms of radius. We also have a formula for electrostatic potential energy, U. We discussed this in electrostatics chapter, right? That is minus product of charges by 4 pi epsilon naught and the distance between them. So this is the electrostatic potential energy, and this negative sign indicates that there is force of attraction between those two particles. So my total energy will be the sum of kinetic energy plus potential energy. When I add them, I got the kinetic energy to be E square by 8 pi epsilon naught r, and the potential energy as minus E square by 4 pi epsilon naught r. So the total energy is minus E square by 8 pi epsilon naught r. This is the total energy of an electron which is revolving in an orbit of radius r. Note that. So here it depends on r because pi, epsilon naught and e are constants, right? And note that this energy is negative, because if it were positive, first of all the electron wouldn't have been rotating in the orbit. it would have gone out of the atom. And hope everything is clear till now. Let us solve a problem. It is found experimentally that 13.6 electron volts energy is required to separate a hydrogen atom into a proton and an electron. Compute the orbital radius and the velocity of electron in the hydrogen atom. Now, a nucleus of hydrogen atom is nothing but a proton. Well, there is an electron in this orbit. The energy of this electron can be given by the formula just we did according to Rutherford's model. Well, it is minus e square by 8 pi epsilon naught r, right? And it is given as 13.6. That is the energy required to separate a hydrogen atom into proton and electron. That is to take these two particles far away. That is taking the electron to infinity. That's it, right? So I should have to give this much amount of energy, and that is given as 13.6 electron volts. 1 electron volt is nothing but 1.9 into 10 power minus 19 joules. So this is the amount of energy in joules, that is equal to 2.2 into 10 power minus 18 joules. Okay, this should be equal to this one, right? I have to give energy, so it will be negative here also. I'll equate both of these. So finally I'm going to get minus e square by 8 pi epsilon naught r is equal to minus 2.2 into 10 power minus 18 joules. I know the value of E, it is 1.9 into 10 power minus 18 minus 19, sorry. And I know, I don't remember the value of epsilon naught, but I always remember it this way. 1 by 4 pi epsilon naught will be 9 into 10 power 9. So from this I can write the equation as what? My R will be minus e square by 8 pi epsilon naught E, and that can be written as minus 9 into 10 power 9, that is 1 by 4 pi epsilon naught by 2. This makes it, right? It is 1 by 8 pi epsilon naught. And here I have E square, that is 1.6 into 10 power minus 19 whole square by what is left, energy, that is minus 2.2 into 10 power minus 18. And just solve it. You are going to get the answer as 5.3 into 10 power minus 11 meters. So this is the radius of that orbit. And how to find the velocity? We just got the formula of radius, right, in the previous slides as this one. We equated the centripetal force to the electrostatic attraction force, then we got something like this. So now you know the radius, you just have to find the velocity. From this equation, velocity can be given as E by root of 4 pi epsilon naught mr. Since you know the value of r now, and rest of them are just constants, and mass of electron is 9.1 into 10 power minus 31 kg. So just put the values, you're going to get velocity of electron as 2.2 into 10 power 6 meters per second. Rutherford's model was a great step in deciding the structure of atom, but there are some limitations for it, like it was not able to explain atomic spectra. That is one of the major limitations. Now you will get a question, what is atomic spectra? In the next video I'll explain it. I'll start the next video with it. So keep watching. Bye.